We're here today at the Cumbie Water Treatment Plant in Lakeland, Florida, where we're going to see how we get our drinking water. So sit back, relax, and join us on this science quest. I'm here with Eric, the water plant chief operator, who's going to take us through the steps of how we get that drinkable water. Eric, what's the first step?
Morning. The first step in the process here is we have one of our production wells here. All the water that we get here for the city of Lakeland is groundwater. So we're pulling out of the ground. And this particular well is drilled 800 feet deep.
Okay.
And each of our wells is capable of producing about 4 million gallons a day. This entire treatment plant is rated at 8 MGD, or million gallons a day. Currently, we're processing about 4 million gallons a day. So this is the first step of the process. From here, the water is pulled out of the ground and is sent through our process. And we'll go to the next step.
Okay. All right, Eric, so the water's pumped out of the ground. Where does it go to next?
Okay, the next step that the water goes through is it goes through this green pipe. The color coding you see here at the water plant, all the olive green indicates that that's a raw water line that's untreated. What we do here at the water plant, the treatment process we use here is called a split lime softening. Because the aquifer that we're pulling out of is limestone, calcium carbonate. As the water passes through that limestone, of course water is a natural solvent, so as it's passing through that limestone, it tends to dissolve a lot of minerals into the water, calcium being the predominant mineral.
Okay.
Causes water to be hard. So what we do here at the treatment plant is we split soften, which means that a portion of the flow bypasses the softening process and goes to the filters. The other part goes to the softening process. So we do about a 60-40 split. So we're softening about 60% of the water that's coming into this facility. So this is what we call our splitter box. Basically, it underneath here is another raw water line that's buried under the ground. It goes into that half of the box. The water then flows to either one of these softening basins here that we have online that are actually softening the water.
Okay, and what's the light blue pipe?
The light blue pipe indicates that it's partially treated. We color code that because at that point it does have some chlorine in the water.
Okay.
So it's not totally raw at this point. There is some treatment process going on already.
Okay. Now these are pretty huge pipes, and you mentioned earlier about 4 million gallons per day?
Per day.
How much is getting siphoned into where? Is getting split into where?
Well, like I said, the half of this, the water that's coming in here, there's another pipe underground here. And so right now there's about 2.5 million gallons a day going underground to that side of the splitter box, going to the softening process.
Okay.
About 1.5 million right now is going through this pipe.
Okay.
Now this plant is designed to eventually build out to a 24 MGD plant.
Oh, wow.
So this piping that's here in place is capable of handling 24 million gallons a day going through it.
Well, that's a lot of water.
It is.
Well, shall we see the next step?
All righty.
All right, Eric. So the water's pumped up from the ground, taken to the chamber where it's split into going to get softened or to get hardened. We're at the softening part now, correct?
Correct.
All right. Tell me a little bit about it.
All right. How we actually soften the water is we use a product called calcium oxide. Calcium oxide is simply calcium carbonate that has been fired, and all the oxygen driven off, the O2, and what you're left with is CaO, or calcium oxide. And what we do is when we take the calcium oxide then, and we'll go inside here in a minute, and it's mixed with water into a slurry. That slurry then becomes calcium hydroxide.
Okay.
The calcium hydroxide is then pumped up into the softening basins that we'll go to a little bit later on. There it's mixed with that portion of water that's being softened. And what happens in the softening process is, we're all taught H2O being water. Here at the water plant, we sort of look at it more of HOH. You still have your 2 hydrogens and one oxygen. So, we jokingly call it hydrogen hydroxide. And because what happens is basically, we know the pH scale of 0 to 14. As we add the hydroxide, calcium hydroxide to the water, it's going to drive the pH up. So the raw water, which typically has a pH of around 7.3, here in the softening process, that pH is going to be driven up to about a 10.4.
Okay, so it makes it much more of a base.
Much more of a base. Right. And what happens is when you drive the pH that high, the calcium that's in the water that's causing the hardness comes out. Okay?
Okay.
So yeah, as you add more hydroxides, you drive that pH scale up, and the hardness comes out. All right, we'll head on into the slakers, and we'll see the actual slaking process that's going on in there. Okay?
Okay, let's go.
We're here now in the slaker room, and up above us is a lime silo. The lime silo above us can hold 260,000 pounds of calcium oxide. The lime then comes down through the chutes over here into the lime slaker. There the lime, the calcium oxide, is mixed with water into the calcium hydroxide that flows into this collection box here. And then we have the ability to send the slurry to either softening basin that we're on. The slurry then comes into this collection box here, and then we use the water jet venturi to suck the slurry up, and we can have the ability to send it to either softening basin that we're currently on. Now this here is actually our softening basin, also called Clarifier. There's a multitude of physical and chemical processes going on here simultaneously. First, you got the lime slurry, or the calcium hydroxide, being put over here into the center part here, and there inside there is a mixer, and that mixer is doing is mixing the calcium hydroxide with the raw water that's being softened. You got a coagulation process going on here as well. We use a polymer which is coming through this orange line here, and what the polymer does is it bonds with the calcium carbonate and gives it weight, so it settles down. Okay. Because we want clear water coming off the top of these units that's going over to the filters. Now, this unit has 4 compartments. What happens is the flow of water is being pulled up and then sent down over the sides of a skirt down here, and you can see that white cloud down there. That's actually the calcium carbonate. That's in we call it a slurry blanket. And we have collection zones in there, so we can actually collect it, and once it builds up, we waste it out of here. Okay. Okay. So this sludge then, what we call a lime sludge, gets sent from this unit over to our thickener.
Cool. So what I'm seeing is, so this being pulled off right now is it's just the water, and the slurry is sinking to the bottom.
Yeah, the slurry, like I said, is being mixed. Is the polymer is being added to it, giving it weight, and it's settling down. Now this water still has a very high pH, 10.4. So at this point, what we do then is this water gets sent over to the splitter box again. So there it's being blended together with the raw water. Okay. Now we also use a process of recarbonation. So we have a point there that I'll show you in a little bit where we inject carbon dioxide into the water. And what that does, we add carbon dioxide into the water, we're forming a carbonic acid, which is lowering the pH. We do that because what we're trying to do here at the water plant is really manipulate that final pH, and we can do it by the amount of carbon dioxide we add to the water. We use an index called a Langler index. And what the Langler index says is that if your water is 0 on this index, your water is neither scale forming or corrosive.
Okay, so what's scale forming mean?
Scale forming means that as the water passes through the distribution system or through the piping that's out in the community, it'll tend to deposit on the walls of the pipe a calcium carbonate. And what we're trying to do here is the water that we send out, we try to manipulate it so that the Langdor index is just slightly scale forming. We shoot for about a 0.1 on that Langdor index. What that means then is when our water is going through the distribution system, it's plating out a thin eggshell type layer on the plumbing. And what that does, that creates a buffer between the water and the metal pipes.
Well, this is some pretty interesting stuff. So Eric, what's the next step?
Well, the next step after the two different waters are blended together, all of that water then gets sent over to our filters.
All right,
so we'll head over that way.
Awesome,
All right?
let's go take a look.
All right, now that the water has been softened and blended back together with that raw water, it comes from that splitter box and comes up through this large blue pipe to our filters. The filters we have here, we have 3 filters, and the filters are dual media filters. They have 12 inches of sand covered with 24 inches of anthracite. And the filters, the primary purpose of the filters is to remove the suspended particles in the water.
What's anthracite?
Anthracite is hard coal, and the hard coal has very sharp, jagged edges on it, and so it's very effective at trapping and collecting those suspended particles.
Okay.
Suspended particles can tend to hide or harbor bacteria. They'll hide around that suspended material. So the less suspended material you have in your water, the more effective a disinfection process you have.
Okay. And once it's done with this filtration, is it pumped out through this dark blue pipe that's below this light one, or?
No, the dark blue pipe that you see down there is actually where when we backwash a filter, where we're going to see here in a minute, we're going to backwash the filter. We have pumps that actually take water from our ground storage tank, our finished water storage tank. That's the water that we use to actually backwash the filters.
Okay, and what's backwashing?
Backwashing the filters is a process where you reverse the flow of water, basically, through the filters. The water normally is going down through the filters, gravity feeding down to a collection area we call our clear well. Okay. What we do then is we basically take a filter at a time offline, and we put water in underneath the filter media and reverse the flow of water up out of the filters, removing all the particles that it has filtered. And then that water that we backwash then goes over to our wash water recovery basin. Okay. So when we backwash water, it goes over to that large cylinder, that tank over there in the ground. And then that water then gets pumped back to the headworks of the plant, so it gets recycled. Okay. Here.
All right, so we're taking a look at this process of backwashing. Would you mind explaining the steps that are sort of going on here?
Sure. The first step is we isolate the filter. So basically, it stops filtering water. The rest of the other filters then handle the additional capacity. Then we take the water level and we draw it down, which means basically we lower that level down. Typically bring it down to about a foot or two above the media surface. The next step after it's drawn down is we have blowers that blow air under that media. And basically what the air does is it's called an air scour. It's agitating the water, and what it does is it's breaking up the media so that when we do introduce the water into it, it's already, everything's loose and ready to come out. And then what we do is we have 2 different flow rates. We have what's called a low rate, which is very slowly is bringing the water up, and then after a certain period of time it switches to a high wash rate, where the water is then come through at a very high rate of wash, and that's to get the filters. Once it's at its high wash rate, the media is expanded because of the process. And what we do then is we take the flow of water and we drop it back down to a low rate. And what that does, we call that a restratification. What that does, that lets that media able to separate in layers. So even though it's all mixed up during the backwash process, the sand is heavier than the anthracite. So when you let the water flow calm down, those will actually settle into 2 distinct layers again, and then it's ready to be put back online.
Okay. Now, how long does this process normally take?
This whole process takes about 30 minutes.
And how often do you have to do this process?
We backwash each filter every 9 days.
Okay.
So we backwash a filter every third day. We backwash a filter.
Okay.
All right, Brad, we're going into our chemical room here. This is where we house all the chemicals and the feed pumps associated with a lot of the process. Everything in this room we actually use that is for the softening process.
Okay.
So earlier we saw the polymer pipe coming up. This is actually where that polymer is mixed and fed from. This is our polymer system.
All right.
Now the polymer then is that weighting agent, that bonding agent that binds with the calcium carbonate and helps it to precipitate out of the water. But polymers, as these are being mixed with the water, they're forming very long polymer chains. Now because we have to move that sludge through the plant, we have to pump it into trucks and stuff. If we add a product called starch, and what the starch does is basically breaks that polymer chain up to let that product be very viscous.
Allow it to flow a little easier.
Let it flow a little easier because it can get really long and stringy. I'm sure some of us have seen some of the really slimy, stringy stuff. So the starch allows it for us to be able to move it around. All right. We also use in the process a sequestering agent. This is a phosphate-based product. And what we use that for is as the water is coming off the softening basin headed toward the collection box where it's blended back with the raw water, it still has a very high pH traveling that way. It has a pH of about 10.4, and it's still wanting to precipitate out the calcium carbonate. What this sequestering agent does is it sequesters the calcium, basically keeps the calcium in solution so that we don't have a lot of excess calcium carbonate that's being carried over to the filters.
Okay. And why do you want to make sure that there's not excess carried over to the filters? Or?
Yeah, if the water continues to soften all the way over there, and it can overload our filters and actually plug them up.
Oh.
Yeah. So this is a step that we use to keep that from happening. Some of the other chemicals that we also add to the water is we add a chlorine for disinfection.
Okay.
We also add fluoride for dental.
So what are we looking at here? We stepped at this computer. What is it showing us?
Well, with this computer, we can actually look at the filters that we saw earlier, and we can see that this particular is telling us that the filter that we were at, it's showing us our backwash steps. It's telling us that the filter is out of service. The step that it's at right now is at the filter fill. So this will actually, the computer will actually control the whole backwash process. This will count down to a certain predetermined time. At that point, it'll jump to the next step, which is return to service, which it just went to. And now I'll take this and I'll drag it out of the way. And what you're seeing is here, it just changed to blue. And this filter went back in service, so that backwash is complete now.
Very cool. Before we head over to the pump room, you had us stop here. I have to ask why.
Well, I wanted to show you our chlorine gas scrubber. We talked earlier about that we use chlorine for disinfection. And the chlorine that we use is gas, chlorine gas. And to give you an idea of what we're dealing with here when we say chlorine gas, it's a gas in a liquid state. Okay, so and your bleach that you would buy off the shelf at your local supermarket, that bleach typically has about 5% maybe of available chlorine. When you get a little stronger bleach, like what would you use in a pool, that gets about 12 to 13% chlorine. The chlorine gas that we use here is pure chlorine. It's 100% available chlorine. It's a very hazardous chemical. Mm-hmm. We do a lot of safeguards here to protect ourselves as well as the community from the potential of that gas getting off site. Okay. One of those safeguards is this chlorine gas scrubber. If we were to have a leak, chlorine gas leak, this system would be initiated, which basically would shut the room down, contain all the gas, and then start drawing that chlorine gas through this unit. This unit contains 2,000 gallons of caustic soda. So what that does is, as it's drawn that chlorine gas through that caustic soda, it's neutralizing it so it doesn't get off site.
Okay. Well, it's very cool to see, obviously, that there's safeguards here. Because I know chlorine can definitely be pretty reactive stuff.
Very reactive.
After it's done with the filtration, before it goes into the pump room, it's got to go somewhere. So tell me, where is it going?
All right. The water is collected underneath the filters in a clear well. That clear well then is pumped by way of transfer pumps that we'll see here in a minute through that large blue pipe behind you over to this ground storage tank. Now this reservoir here can hold 5 million gallons of finished treated drinking water for the customer.
A lot of water.
Yeah.
Okay, Eric, we've seen the process. We've seen the water brought in from the well, separated. Some of it is softened. We see that taken to the filtration system, goes through that, it gets stored. Now we're in the pump room.
We're in the pump room. Now, as you can tell, it's a little noisy in here. This is where a lot of the bigger pumping equipment is housed. The two pumps that you see behind you there, those are our transfer pumps. So those are the ones that we talked about earlier that are transferring that filtered water over to the ground storage tank. And the other pumps down here, there's 3 smaller pumps you see right there. Those are the pumps that are used for backwashing the filters. Those are the wash water supply pumps, we call them. Down on the far end there are our high service pumps. Those are the pumps that actually take the water from the ground storage tank and pump it out to the customer. These pumps here actually supply the pressure as well as the flow. The city of Lakeland has no elevated tanks for their water pressure. All of the water pressure for the city of Lakeland comes through these variable speed pumps. So basically we tell the computer, we want you to maintain a certain pressure. So the pumps will ramp up or ramp down to maintain that constant pressure throughout the city.
Now, I know at some point you have to test the water, so where do you guys do that?
Well, we'll head on into our lab.
All right,
okay?
Let's do that.
All right, bro, Brad, here we are in our lab. In here is where our operators come in here, and they run water quality tests every hour. They're looking at different areas of the plant, different process, evaluating the effectiveness of the process. They're looking at how well the computer, which we have here, which controls the whole plant, is adjusting flows and stuff like that, and adjusting chemicals properly. Every area in the plant that we're concerned about testing the water from, we have sample pumps in those areas that bring the water into the lab. So the operators don't actually have to go out in the field. They can stand right here and sample water from all different processes. So some of the things that they're looking for in here is pH. Okay. We talked about earlier about we want to get a slightly positive Langler index. So we tell the computer what we're shooting for. They're back here making sure that that whole process is working. They're looking at the final pH of the water. They're also looking at the pH of the water in the softening process and the raw water as well. We're also looking at chlorine residual. So this station here is where they titrate for free chlorine. So what we're looking for here is about a 1.5 milligrams per liter of free chlorine going out to the customer. Okay. All right. This station back here is where we're looking at alkalinities and we're looking at hardnesses. We're looking at the raw water, hardness, alkalinity. We're looking at the softening process, hardness and alkalinity. And then we're also looking at the finished water, hardness and alkalinity. This station here is where we're looking at turbidity. And we talked about turbidity on the filters.
Yeah.
What we're looking at is to make sure that our filters are effectively removing all of these suspended particles that are in the water. And we typically have a value here on this meter of finished water of about 0.05, 0.06 NTUs. Okay. The MCL for turbidity in the state is 1 NTU. So we're at 0.05 on the NTU
much
meter.
Lower than the...
much lower.
Value.
We're also looking at fluoride residual. We talked about putting fluoride in the water. So we have a meter over here that actually measures our fluoride concentration that we're putting in the water to make sure that it's not too high, not too low. And then we're also looking at our phosphate residual. So we did talk about a phosphate product that we put into the water. We're just, we also look at that, just make sure that that phosphate product is where it should be at. These are the cones, and I had them collect those. That's just to give you an idea of what we do. We take samples out of that softening basin. These here are sample cones out of the softening basin, and what they do, they collect these every other hour, and they're looking at how much of the sludge, how much sludge is being produced in that softening basin. So there's what actually looks like what we talked about, calcium carbonate sludge. That's an example of what it looks like after it's settled in that MHOP cone. In addition to all the samples that the operators are doing here, that they're doing every hour, on the hour, 24 hours, 7 days a week, holidays, the water never stops flowing. So the operators are always back here making sure that we're putting out the best quality water for the customers. In addition to all the tests that are going on in here, the City of Lakeland also has to go out and collect 120 samples a month in the distribution system and analyze those for bacteriologicals. Okay. In addition to that sampling, we also have what's called triannual sampling, which is a whole battery of tests that we're required to do, which looks at heavy metals, looks at radiologicals, pesticides, PCBs. So we're looking at, every 3 years, the whole gamut of the water quality.
All right, so a lot of tests to make sure this water is safe to drink.
A lot of testing going on, yes.
Well, that's very good to hear. Well, Eric, I've seen a lot here. This is a huge process you have going on, but I have to ask before I go, how do you run it all?
Well, here at the company plant, we have a computer system that handles the entire process. Let's go and take a look.
Okay.
We're in here in our control room. From here, the operators have the ability through this computer system to look at the entire process. Right here, what you're seeing here is an overview screen. So the operators can look at this screen, and anything you see that is red on that screen means that it's running. Anything green means, of course, that it's off. All the key points in the plant, all the process that we're looking at, we define what those parameters are. We tell the computer we want you to stay in this range. And the computer will adjust what it needs to, adjust the process to maintain that particular set point that we give it. If anything was to get out of range, this system would have an alarm attached to it. So we would automatically get an alarm, and the operators would be able to look at that point and see what the computer was telling it was out of range. So, for example, in here they can drill down, they can click on high service pumps. Well, it's already up over here. So there you're looking at the high service pump screen. So it's telling you from here they can look at that area, they can tell which pump is running, how fast it's running. They can also from this screen look at our plant flow going out, our plant pressure. So each area of the plant has that capability for operator to control. Like I said, the computer is controlling everything in auto, but the operators also have the ability to go in and override that computer and start and stop things manually, all from this control room here.
Now that other computer station we were at earlier, the program looked very similar to this. Are you able to do the same things on that computer as you are on your master control here? Yeah,
this system is actually what we call a DCS system, which stands for a distributed control system. What that means is that there are 4 major areas to the plant we've defined, and those areas have those computers that you saw there, those screens. And inside those controls there is a controller that will control everything in that process. You actually have 4 different areas of the plant that are operating independently of each other. But this control system, it blends them all together, merges them, and you see them all together here. The operators, wherever they're at throughout the plant, they don't have to be here to operate. They can operate the plant in the chemical room, in the pump room, up on the filters. Anywhere there's this workstation, they'll have full alarm capability and full control of the plant wherever they're at.
Well, Eric, I want to thank you so much for letting me come out here, pick your brain, and just see the whole facility. It's good to know that the water plant's in good hands.
Thank you, sir. Appreciate it.
Well, that's all we have for today. Join us next time as we seek out yet another Science Quest.